Hey everyone, in this video we're going to take a look at the limit of a difference quotient. Now this is a really important idea in calculus, and it's going to set us up for one of the biggest, most important ideas in calculus that we're going to see later on. So as we're going through this, I want you to pay special attention to it, internalize it, because this is going to come back and we'll see it again. So I want to illustrate this with an example. I think the first thing we should do is just remind ourselves what the difference quotient is. The way we define this is it's f of x plus h minus the original function f of x all over h. And just additionally on here, h cannot be 0. Okay, remember what the difference quotient is we're finding the slope of the secant line between 2 points on a curve. So let's take our original function. So my example here is f of x is equal to 2x squared minus 3x plus 1. And I want to find the difference quotient of this. So I like to do this in pieces. So I'm just going to start off by finding f of x plus h. So wherever we see an x in our function, we'll substitute in x plus h. So we have an x plus h squared minus 3 times x plus h, and then we have a plus 1. And now let's just simplify this as much as we can. So the first term, x plus h squared, it's a binomial squared, so that's the same as x plus h times x plus h. And if we multiply that all out, we have an x squared plus 2xh plus h squared. So binomial squared, they always follow this same sort of pattern. Distributing the 3 minus 3x minus 3h, and then plus 1. And then the last thing, distributing the 2. And this is actually all the simplifying that we're going to be able to do. So plus 2h squared minus 3x minus 3h plus 1. All right, so now that we have that, we can find our difference quotient. So again, our difference quotient, f of x plus h minus the original function all over h. So let's plug in what we know. So we already figured out f of x plus h. It's this big long expression, so I'm going to rewrite all of this. And then from that, we're going to subtract our original function, and I'm going to put it in parentheses so we know to distribute the negative sign. So our original function was 2x squared minus 3x plus 1. And then this whole thing is all over h. Okay, let's take a look at that numerator and see if we can simplify anything. We should have some things that cancel out. So here's a positive 2x squared, and then we're going to subtract a 2x squared. So that will result in 0. Here's a negative 3x minus a negative 3x. So that turns into plus 3x. So this will also give us 0. And then lastly, we have a positive 1 minus 1. So that will simplify as well. So let's see what we're left with. We have a 4xh plus 2h squared minus 3h, and this is all over h. Okay, now the last thing we can do is if I look in the numerator, all three of these terms have an h in them, and I'm dividing by h, so I can divide out that factor from each of these. So simplifying that h, what I end up with is 4x plus 2h minus 3. So this is our difference quotient. So that's the first thing I wanted to take a look at. Now, the second thing I want to do is actually want to find the limit of this difference quotient. So what I want to take a look at is let's consider the limit of our difference quotient. And I think it's an interesting question to figure out what happens as h approaches 0. So remember, up here, when we were defining what the difference quotient is, we said that h cannot be 0. So what happens as we get really, really close to that? So the limit as h approaches 0 of our difference quotient, even though there's multiple variables in here, this is all pretty simple operations, so we can just plug in 0 for h. So we get 4x plus 2 times 0 minus 3. What we end up with then, as h approaches 0, our limit is 4x minus 3. So there's our solution. So in other words, what we're looking at, and just to give you a really quick idea, I'm going to sketch out a curve here. So this is just an example. I don't know what this function actually looks like, but when we're looking at our difference quotient, we pick out 2 points on this curve. So let's say that this one is x, and then we look at another point, and we'll say that this is x plus h. And the difference quotient is we're finding the slope of the line that goes in between these 2 points. So we're finding the slope of this secant line. Well, now what I'm doing, if I'm asking the question, what's the limit as h approaches 0? What I'm doing is I'm moving this point closer and closer to x. So if h is approaching 0, so h is getting closer to 0, that means the distance between these 2 points is getting close to nothing. So that means that this point is moving along our curve, and it's also getting closer and closer to that. So what happens to our secant line as that happens? So again, I want you to keep that in mind because that's an idea that we're going to come back to, and it's one of the most important ideas in calculus.